Okay, let's get started. You have this page that I gave you because there is a lot of graphing located on this with scatter plots and lines of fit. So I'm going to use this as our notes page. So let's get started. Okay, so one of the things that we're going to do is scatter plot. So this would be having an experiment. You've done it. You want to see if there is a relationship, okay, between data sets. Okay, relationship between data sets. So we're going to graph the ordered pairs, okay, which sometimes can be tricky when you try to figure out what your axes should be. And I'm sure you've done this in biology. And then we're going to see if there is a trend to the data, okay? So the first thing we're going to do, we're going to work on is interpreting graphs. Okay, so I'm going to increase my view a little bit. Everybody see that okay? So let's work on trying to interpret these scatter plots. The scatter plot shows the amount, X, in grams of sugar and the number of Y calories in 10 smoothies. Okay? How many calories are in a smoothie that contains 56 grams of sugar? Okay, so notice, so sugar, okay, the sugar is the X value, right? And here's my X values. Okay, and notice I have two different graphs, don't I? So I have, well, no, I have smoothies here, and I think it's the same exact graph. I think it's just showing us how to do it. So here we go, 56 grams of sugar, okay? 56 grams of sugar. So I'm going to go up from 56. Now that's probably in between, right? 50, okay? And I'm going to go up until I hit this, oh, right there, till I hit that point, okay? Till I hit that point, and that's 270. So 56 grams of sugar, 270 calories, okay? All right, how many grams of sugar are in a smoothie that contains 320 calories? Okay, well, now which piece are you given? Well, in this case, I'm given the Y value. Now I need to find the X value. Okay, so in 320 calories, how many grams of sugar is that? Well, 320, let's see, is anybody, oh, right there. What is that number? 70 grams of sugar. Okay, what tends to happen to the number of calories as the number of grams of sugar increases? So what do you notice? Okay, well, it seems to increase. So as the calories, as the sugar increases, so do the calories. And that's really true when you have something that has that, has sugar, it's added calories. Okay, so here we go. This is your turn. How many calories are in a smoothie that contains 51 grams of sugar? 51 grams. So let's see, 51 right there. I would say probably 260. That looks like that number right there. 260 calories. Okay. And how many grams of sugar are in a smoothie that contains 250 calories? Well, 250 calories is right here. Right there. So what is that number? I'm going to guess it's between 50 and 54. So I'm going to guess 52 grams of sugar. But you know what? I'd really like to be able to figure out this exactly. So let's take a look. So we want to be able to actually give a numerical value to the correlation, okay? An actual like correlation or what we get from this. Okay, so we want to be able to calculate or look at the relationship between these 2 points. As one goes up, the other goes up, or as one goes down. So you have types of correlation. And here's pictures with each of these to help you. You have a positive correlation. As one goes up, so does the other. And it has a positive slope right here. See? Going up. Then you have a negative correlation. As one goes up, the other goes down. It has a negative slope. And the other one, if you ever get to like, you're looking at data and you have no idea which way you should draw it, there might not be a correlation at all. Shows no patterns. Is there any pattern behind the size of someone's foot and their intelligence? No. Again, but you could look at that and see if you could find a trend. Okay, so let's just take a look at and see if we can identify some trend lines. Okay, let's see. I'm going to take my handy dandy ruler, because here's the rule about drawing a scatter plot, is that whenever you draw a scatter plot, you want to split the points above and below your line. So I like to put, ooh, I don't really know how to, yikes. If I don't really know how to draw this, then you probably don't have a correlation. If you're not sure how to split. Now look at, this definitely looks like a trend. In fact, if I put my ruler, oh my goodness. I'm just drawing this kind of slappy. But look, if I draw this, man, I've almost got all of them, don't I? And if I look from left to right, I go down a slope. So this would have a negative correlation. So what this means, so let's talk about this. Let's look at, so as average daily temperatures, okay, increase, okay, so average daily temps increase, what happens to coats sold? The number of coats sold decreases. That's true. People don't buy coats in the middle of the summer. Okay? So that should make sense. All right. All right, here we go. So we're going to make a scatter plot. Okay, and this is where it gets a little time intensive. Okay, so let's look at our data and let's see if we can. So the first thing I'm going to do is I'm going to label my axes. So I'm going to go temperature down here, temp, degrees Fahrenheit. Okay, this is going to be my X, and attendees by the thousands. Okay, that's on my Y. I'm going to put this over here. Okay. All right, here we go. Let's see. I go, what's my low and what's my high? Here's my low. So I can go by ones. Start out 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, what's my temps? Let's see. Looks like I can go, got to go up to 90. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay. Sometimes we have to do like skip, like we'd have to skip to get everything put together. It really just kind of depends. Okay. Okay, you ready? All right, so let's just graph. So this takes you a little bit. So 82 and 4.5. Okay. And 78 and 4. And 68 and 1.7. Not quite there. Okay. And 87 and 5.5. And 75 and 3.8. And 71 and 2.9. 92 and 4.7. And 84 and 5.3. Whew. Those are really clustered together, aren't they? All right. Maybe I should have spread those out a little bit next time. Okay? All right. So, if I were to take a line, I'm going to use a red pen and try to split these points, right? Boy, I've got that one I've got to get. Huh. Maybe? Well, I know I have one over here. I was trying to split the difference. Well, what kind of slope does this have, friends? You're right. This has a positive correlation. Okay, positive correlation. Okay, so with this, I'm going to go ahead and I am going to show you how to calculate and actually do the line of best fit, how we can actually calculate the slope of the line. Okay, so number one, pick 2 points on the line. Now, they do not have to be points from this table. They can be any points on the line. I want you to take a marker or something and highlight the 2 points. They had better be on the line, okay? So this point did happen to be in my data set, and it was 68, 1.7. And this one was, what, 85, 87, 5.5. Again, you don't have to use points from the table. Just make sure they are on your line. Okay? Make sure you identify. Next step, number 2, find the slope. X1, Y1, X2, Y2. So here we go. 5.5 minus 1.7 over 87 minus 68. Use your handy dandy calculator. It will be okay to get a decimal. So I get 3.8 over 87 minus 68, which is 19. 3.8 divided by 19 is 0.2. Okay, you can leave it as a decimal. No big thing. Okay, well, you know how to do the rest. Number 3, okay, find y-intercept. Okay, pick one of the points. Okay, so I'm going to, for this, I'm going to use an orange marker. I'm going to pick this point right here. I have my slope, which is my m. I have my point. So I'm going to rewrite this point down here as my x and y. I have my m. Life is good. Y is equal to mx plus b. 1.7 equals 0.2 times 68 plus b. And I'm going to figure out that 0.2 times 68 is 13.6. And I'm not going to be worried because I can do decimals. I have a calculator. So 1.7 minus 13.6, and I get negative 11.9 is B. Step number 4, rewrite your equation. Y equals, my slope was 0.2, and my y-intercept was negative 11.9. Now that might look kind of weird, but notice my graph, and if I were to continue down, it would probably hit somewhere. Think about it. If I had this replicated down here, that would be pretty accurate. Okay? So you're going to come back and you're going to do that exact same step, but you're going to do it with number 4 on here. Let me give you a suggestion. Okay? Let me give you a suggestion. For your ages of your cars, okay, you could do 1, 2, 3, 4, 5, 6. You could do that, okay? For this on the side, I would go by 3s. 3, 6, 9, 12, 15, 18, 21, 24, okay? That would be my suggestion, okay? This would be ages of cars in years. This would be value in thousands, okay? So part of your homework here is going to be to come back and then find the line of best fit. Okay? All right. So I did find, okay? So let me just go back real quick to reiterate one more time your steps to finding the line of best fit, okay? All right, number 1, a line drawn on a scatter plot that is as close to most of the data points. And we're looking at the trend. Now, can you get that wrong? Sure you can if you don't try to split the points. So don't just willy-nilly. Make sure that you think about it when you're doing it. Okay, so you make your scatter plot. Okay. Model or draw the line. Okay, figure out if it's positive, negative. Okay. Draw the line and then write an equation using 2 points on the line. Okay, so stop here. You're going to go back to this example, the second one right here, and you're going to finish that for homework tonight. Okay, thanks, friends.